Hi everybody, this video is going to cover lesson 7.1, which is on rational exponents. We are in the unit on radicals and functions. Our first half of the unit is radicals, which is what we're covering today. Some of this is review, so I'm just going to jump in and hopefully go pretty quickly through the review. We learned last unit, in fact I'm going to switch back to a screen. Let me show you. You have a little list of squares and cubes. It was little, I think it was yellow, squares and cubes on one side, shortcuts on the other side. You should have this little piece of paper with you because this is going to help you with this section as well. So when we talk about taking square roots, x to the 6 is like 6x's, right? But the square root is like the second root. There's like a little 2 in that corner, which means we need to find how many groups of 2 are there. Well, there are 3 groups of 2, so the answer is x to the third. So x to the 6, the square root of x to the 6 is x to the third. Or if it's a cube root, then you group them in groups of 3. And if you do that on x to the 12th, you have 4 groups, and so that is x to the 4th. And then we realize really you can just divide. 6 divided by 2 is 3, 12 divided by 3 is 4, and 20 divided by 4 is x to the 5th. If you have numbers involved, it's the same thing. You just have to consider them also. So 32 is 2 to the 5th. 1, 2, 3, 4, 5 of them. And remember, this is again second power, or second root. So we have 2 groups, that's 2 to the second, and we have another 2 that's left over, and so it has to stay inside. And with our x's, we have 1 group, and we have 1 inside. And so this simplifies to 4x times the square root of 2x. And I'm going to draw my line a little bit longer to make sure I cover that whole thing. Okay, then when we get to 80, I'm going to switch colors so we can see. 80, you could also list it out all the way like this, but then we also talked about how we can look for the perfect square that goes in. And 16 goes into 80 5 times. And x to the 4th, well, that's actually a perfect square already. So the square root of 16, let's take the square root of all of this. Square root of 16 is 4. Square root of x to the 4th is x squared. And then 5, that one's left over, so this is 4x square root 5. Third root is similar. Now we're just on our perfect squares list. We have to look at the cubes because 8 is 2 to the third, and so that is 2. And x to the 6th, the cube root of that is x squared because 6 divided by 3 is 2. All right, we also have higher roots. We have 4th root, 5th root, 6th root, whatever. So 625, I don't remember if that's on your list or not, but let's think about it. 5 times 5 is 25, times another 5 is 125, times another 5 is 625. So the 4th root of 625 is actually just 5. And 12 divided by 4 is x to the third. So that is that answer there. Remember, if it's not a perfect square, this is like 25 times 2. And then we still have our x squared. So 25 is a perfect square. X squared is a perfect square because x, and the 2 gets left over. Finally, when we have fractions, what we do is we take the square root of the numerator, the square root of the denominator. So the square root of the numerator is 7x, denominator is 4. Okay, back in that unit where we were doing this also, we learned that x squared times x to the third, there's 2 of them here, there's 3 of them here, that's like x to the 5th. So we said, oh, you can just add those together. But if it's x squared to the 4th, that's like you have 4 different sets of x squared, and so that means you must have 8 of them altogether. And then we also talked about there's like a distributive property with these. So this is going to be x to the 5th, y to the negative 20th. And that x to the 5th stays in the numerator, but a negative 20 power has to go down below and become a positive 20. So that's the answer on that one. So now let's talk about fractions, because there are fractional exponents. So that actually is what this one is about. This whole unit is about fractional exponents. So when we did this, remember, we took 2 plus 3. And so if we do this next one, we have to take 1/2 plus 2/3. Well, what's 1/2 plus 2/3? Well, that's 3/6 plus 4/6, which is 7/6. So this is x to the 7/6 power. And if we have x to the 6 to the 1/2 power, well, up here we multiply 2 times 4 is 8. Here we're going to multiply 6 times 1/2. That is third power. And again, we can distribute this. So this is x to the negative 3, y to the 1/2. Oh, that's kind of weird. Well, the fact is 1/2 means square root. So this means the square root of y over x to the third. Let's just take a minute to review a couple of things. 9 to the third is like 9 times 9 times 9, and that is 729. 9 to the second, 8 times 8 is 81. 9 to the first is just 9. 9 to the 1/2. 9 to the 1/2 means the square root of 9, and that is 3. Whereas, I'm going to go this way now. 9 to the negative 2, that's like 1 over 9 squared, and that's 1 over 81. 9 to the 0, anything to 0 is 1. 9 to the 2/3, how do we do that? Well, the way we do that, and we're going to learn this down here in just a second, is we say that this is 9 squared, and we make it the cube root. And so I will tell you that that one actually doesn't simplify, does it? We're going to leave it like that for now. We'll talk about how to simplify them. For now, we'll leave it like this. This one, though, is the cube root of 9, and again, does not simplify because there's no number that if you multiply it times itself 3 times would get to 9. Okay, so when we have these fractions like this, the top number is the exponent and the bottom number is the root. Yikes, my arrow's not really going there. So when we write it, it is n to the a power with the b here in the root. All right, let's do a little bit of investigation or practice with this. So 9 to the 1/2, the radical form, 1/2 means square root. So this is the square root of 9, and that is 3. The base in this case, remember the power or the exponent is the little number up here, the base is the big number. So the base is 9, and 3 times 3 is 9, that's a times. And so that's why the 1/2 power is 3. How about negative 8? The radical form would be the cube root this time because it's a 1/3 of negative 8. The answer is negative 2. Why is it negative 2? Because negative 2 times negative 2 times negative 2 is negative 8. The next one, 1/4 power means 4th root. The 4th root of 81 is 3 because 3 times 3 times 3 times 3 is 81. And lastly, 3rd root of 1000, we write it as the 3rd root like this. That's a 3rd root. And it is 10 because 10 times 10 times 10 is 1,000. All right, let's turn the page. So let's use that we just did a second ago. There's actually 2 ways to simplify this, but it's just to write it. Remember, the top number is the power and the bottom number is the root. So this is 25 to the 3rd to the 2nd power. Okay, how do you do that? Well, you could take the square root of 25 to the 3rd. Holy cow, what's 25 to the 3rd? It's a really big number. I don't even know what it is. It's 15,625. And we need to take the square root of that. I don't know how to do that in my head, and I'm kind of lazy. I want to do it in my head. So instead, I can do it the other way. The other way is I can take the square root of 25 and take that to the 3rd. And that's a lot easier for me because I know the square root of 25 is 5. And 5 to the 3rd is 125 because that's on my list. Okay, let's look at another one. This one with an 8. So 8 to the 2nd, and it's the cube root. Okay, we can think of it as the cube root of 64, or we could think of it as the cube root of 8 squared. Either way, it's going to be the same thing because you might know that the cube root of 64 is 4. Cube root of 8 is 2, and 2 squared is also 4. So you can do it either way. All right, we might not do every single example. This x to the 4th root of x like this, we could write it as x to the 1/4. This one we could write as x 6 over 3, which is x squared, or 6 divided by 3 is 2. Now, this one, they're both the same root, so that's helpful. That means that we can now multiply x squared times x to the 18th. And x squared times x to the 18th is x to the 20th. And so now 20 divided by 5 is 4. When you have the same root, you can also put them together as a fraction like that. So we keep our x to the 4th and our x, but the cube root can go over all of it. And x to the fourth over x is just x to the third, and the cube root of x to the third is just x. When you have the same root as you do the power, that equals 1. So like 3 divided by 3 is 1, right? That's just x. Now this one down here at the bottom, that one actually can't be simplified. Well, I guess you could. You could say x to the 2/3 over x to the 1/2. And remember, if we do this, we subtract. So then your question is, okay, what's 2/3 minus 1/2? Well, that's 4, 6 minus 3, 6. That is 1/6. So you could say that this is x to the 1/6 power, or the 6th root of x. All right, all of those were just x's. What if they have numbers in them? Well, we have to think about how to break up those numbers. So like 4 times 2 is 8. So that means, and x squared is a perfect square. So the square root of 4 is 2. The square root of x squared is x, but the square root of 2 stays inside there. Similar deal with cube root. We have to look at our cube root list. Look at your cube root list. What goes into 375? Well, as it turns out, 125 goes in there 3 times. And then I have x to the 4th. And this is a cube root this time. So cube root of 125 is 5. Now the cube root of 3 has to stay inside. X, I can take 3 of them out and 1 of them left over. So that cube root is 5x cube root of 3x. 32, again, that's actually on our list. 2 times 2 times 2 times 2 times 2 is 32. That means the 5th root of 32 is 2. And the 5th root of 13, another way to think about it, is 13 divided by 5. 13 divided by 5 is 2 with a remainder of 3. Okay, how about negatives? You can do negatives with cube roots. Not with square roots, but you can with cube roots. Negative 27 is actually, 27 is on our list. And so we're taking the cube root. So the cube root of negative 27 is negative 2. But the cube root of 2 does not have a cube root. And then 8 divided by 3 goes in there twice with a remainder of 2. Y to the 12th divided by 3 is y to the 4th. So your answer is negative 2, x squared, y to the 4th, cube root 2x squared. Just real quickly, remember that the 1/2 power means the square root of 9, which is 3. The negative 2 power means 1 over 9 squared, which is 1 over 81. So those are obviously two very different things. And I just bring that up because sometimes people get them confused, the 1/2 and the negative 2. Okay, how about if we have a negative fraction? Ugh. Well, for the negative, if you remember, we have to turn it upside down. So that takes care of the negative. Then that 2/3 power can go on both. So this can be 27 to the 2/3 over 8 to the 2/3. Okay, well, what does that mean? Well, that means the cube root of 27 squared, and this means the cube root of 8 squared. And remember, you can square it first and then take the cube root, or you can take the cube root first and then square it. I know that the cube root of 27 is 3, so this is 3 squared, which is 9. And the bottom, that's a 64. Cube root of 64 is 4. Okay, that is some basics about how to do both exponents and radicals.